Hi, and welcome to my presentation. My name is Magnus Longva. I graduated 3 years ago, and this is a short summary of my relevant experience on this matter. I spent 1 year at Deloitte in 2019 as a CDF task maker, and from the summer of 2020 until now, I've been a consultant at Bovea. But they are in turn hiring me out to Equinor, where I do infrastructure and platform engineering. I'm not a security specialist. In fact, I'm not even my team's security champion. That honor is bestowed upon someone else. But I do consider myself to be more than averagely interested in security, certainly for a developer. My talk here today is about DNS and particular shenanigans that you can do with DNS. So before I go to the core of my topic, I need to give a brief overview of how DNS works. So if you look at this diagram here, on the left-hand side, I have some client machine who is making a DNS request. In this particular scenario, it is a Kubernetes pod. And it is making this query here. It wants to find out which A record contains the IP address for sub.underhensikter.no. It sends this request to the core DNS resolver inside the cluster. And in this particular scenario, the core DNS resolver will forward the request to Azure DNS. And then Azure DNS does the recursive resolution here. It will figure out, okay, the .no zone, which server is the authoritative name server for that zone? It will ask the root name servers in order to get the answer to that question. And that will be something like this, niet.nori.no. It is one of many. And then it will in turn ask that name server, what is the authoritative name server for the underhensikter.no zone. And it will presumably get the answer to that as well. It is ns.sikkerhetshull.no. And when it has all this information, it is ready to make the final request, which is what is the IP address of sub.underhensikter.no. And if all goes according to plan, the correct IP address is returned and is sent all the way back to the client. But there is a plot twist in this diagram. And that is that I control the authoritative name server for the underhensikter.no zone. It's mine, it's actually true. And the main takeaway you need to remember from this diagram for the rest of the presentation is that on the left-hand side there might be a firewall which surrounds the pod on the left-hand side. But no matter what sane firewall configuration you apply here, you are almost required to allow outbound DNS. You are going to run into a lot of trouble if you don't. And no matter what restrictions I apply to this IP-layered firewall, I would have to allow this request to be bounced around the world until it reaches my evil name server. There is nothing the client can do on the firewall level to prevent this. So just remember that, and you can forget everything else about this diagram, but remember that detail. So DNS exfiltration. What is that all about? So imagine that the pod on the left-hand side on the previous slide is compromised through some arbitrary exploit. And on that pod, there is an environment variable, the database password, and it looks like this. Now, assume that this pod has a very strict firewall which prevents nearly all outbound traffic. But the attacker wants to know the value of this environment variable. Well, one option, if you are so lucky that you own the authoritative name server for some DNS zone, is that you can send this value home through a DNS request. You would trick the client into resolving a domain where the first term of the subdomain is equal to the value of whatever you're trying to exfiltrate. So if you look at this string here, it's equal to the database password. If I trick the client into resolving this domain, then I will read it in my end if I control the name server. So I use DNS for something that it's not supposed to be used for. I hide arbitrary data inside the datagrams. Now, what the server returns here is not important. When I received this request, I got what I wanted. Now, what is DNS tunneling? That's when you take this concept one step further. That you're not only interested in what you receive from the client, but you also send data back to enable two-way duplex communication. So this scheme here can be used to, for example, establish a persistent tunnel between some compromised target and the evil authoritative name server. So in this very simple use case here, the client asks, what should I do next? .underhensikter.no. The name server happily replies, well, you should do this. What you ask for is a CNAME, and inside the CNAME answer section, I tell you what to do. And by using this principle, you can establish a long-term command and control infrastructure. How long has this been a thing? The first recorded technical discussion on this topic appeared in an email on the bug track mailing list in April 1998. Oscar Persson is his name. I frankly don't know if this guy's an American or if he's a Swede. Does anyone here know? Because I would love to know more about the guy. Details about him are sparse on the internet. But I think he's, well, not an irrelevant person in the history of the internet. So he needs a chronicler. Well, he pretty much said that I have grim news, people. Your firewalls are no more. Because all of you people are allowing outbound DNS. And as long as you do, no one is safe. And he described the principle which you can use to establish a DNS tunnel. Well, what happened in the next years? At the Black Hat Briefings Conference in 2004, Dan Kaminsky had a talk. And he presented DNS tunneling, and it was a really hot, bleeding edge new topic there for most of the audience. But he emphasized that he is not the first person to play around with this. It has been done before, and there are lots and lots of private, unreleased stuff out there. He said this in 2004, 6 years after Oscar Persson made this mail here on the bug track mailing list. So even if the system administrators of the world did not pay much heed to his warnings, the black hat hackers of the world obviously did. And DNS exfiltration proliferated as a technique in the next 6 years. I have been looking for the earliest tools to streamline DNS exfiltration and tunneling, and I found these three. NSTX and Iodine are they're not primarily advertised as tools for black hat hacking, but more like utilities that you can use if you happen to be behind a strict firewall, like for example an airplane, and you feel like doing some work, and then you can piggyback off DNS to do what you want. So the tin did not say this is for black hat hackers. It said this is for people who happen to be lucky enough to own an authoritative name server and like doing their work even when they happen to be locked behind a strict firewall. Ozyman DNS, which Kaminsky released at the Black Hat conference, that was definitely advertised for hacking. Yeah, if you happen to be on an airplane, you usually have to pay for Wi-Fi in order to get out to the wider internet. But you are usually allowed to make DNS requests to whatever domain you want. So if you have already prepared an authoritative name server back home, then you can bounce your traffic through that and not pay anything. The first time I heard about DNS tunnels, it was in this young adult novel written by Cory Doctorow, published 2008. I think it's a great read. The protagonist lives in this alternate version of the USA where it has become a full-blown surveillance state, and he's battling various government agencies trying to stay under their radar. In this encounter here, the main character meets this hacker, and she's supposed to show him some evidence of some government malconduct. And her protocol of choice to deliver this video was DNS. It took a few years after I read this for the technical details to fully sink in. But I remember it vividly when I heard about DNS tunneling the next time, and I went back and reread it. There are some things that Dr. O got completely wrong here. DNS tunneling, it ain't anonymous, and it's even less true that it's fast. Anyone who has tried DNS tunneling from an airplane or anywhere else would know this. It will be the worst bandwidth you have ever had. And I don't care how many DNS servers you used. Now, I've been looking through some high-profile data breaches during the past decade, trying to find real hard confirmation that DNS tunneling was part of the attack. And the details are usually sparse to the public, so it's been hard for me to make conclusions here. But we do know almost certainly that in the SolarWinds hack of 2020, DNS tunneling was an integral part of the post-exploitation command and control setup. So there was a Team City server, I think, which was integral to the breach. And after the initial exploit, the attackers set up a DNS tunnel to call back home to maintain control of the server. And then there was the Office of Personnel Management, a less known incident in 2015. There has not been any memo issued to the public about exactly what happened, but what we do know, at least according to this blogger at Cisco, is that immediately after the incident, the Department of Homeland Security arranged a workshop for the OPM where DNS tunneling was very high on the agenda. So I think it's safe to assume that DNS tunneling had something to do with it. And there are two malware groups, OilRig and Exant, who allegedly always use DNS tunneling as part of their modus operandi. I haven't heard their names before, but maybe if you pay attention to this kind of stuff, those are brands you've heard of before. So it's been hard to find third-party sources that confirm that, yeah, DNS tunneling was used here and it was used here. But I'm pretty sure that any black hat hacker worth his salt during the past 20 years keeps DNS tunneling at the very top of his toolbox. Here's a screenshot from the Norwegian NRK where the SolarWinds hack was mentioned. So this made headlines in mainstream news. Yes, so it's time for a demonstration. Do you remember log4shell? Well, yes. I have set up a application which is vulnerable to log4shell. My setup is kind of fragile here, so things might go wrong for any number of reasons. But if they do, I have prepared a video to fall back on just in case. Yes, this is a Hello World program. Let me just stop intercepting these. I have configured this app here to use the log4j library to log the contents of the user agent header upon each incoming request. So I happen to know that if I fiddle with the user agent header, I can make some stuff here happen. Yes, so this is the classic log4j exploit. You use an LDAP lookup to download some malicious jar file from a server which the attacker controls. But in this exploit here, I'm not trying to download a jar file. I know that would not work because the app on the left-hand side here has a strict outbound firewall which would not allow this request to go through. But what I'm trying to do here instead is to look up a domain which I have built dynamically here, where I make the first term of the domain to be equal to this environment variable, which may or may not exist on the compromised machine. We don't know yet. And the rest of this request may fail. I don't care, as long as I can trick the machine on the left-hand side to resolve the domain. The shell on the right-hand side there is from the inside of my authoritative name server, and you're looking at the logs from my bind software instance. Okay, let's forward the request and see what happens. There we go. This string here is the content of this Radix git commit tash environment variable. Okay, let's see if we can find other stuff. What about db pass for db password? It's not entirely unlikely that a web application may have an environment variable like that, is it? Well, let's try. Nothing happened. I'm guessing that means that there was no such environment variable because I tried resolving an invalid domain. Okay, let's try again. What about db password? Nah, that didn't work neither. Well, this is fragile, as I warned you. This was supposed to work. It didn't right now. But believe me, it usually does. Okay. No, I'm sure it's not cached. I've actually never tried this particular exfiltration before. I have one more demo for you. This is a different web app. Some of you may recognize this as the damn vulnerable web application. I have patched it slightly to showcase the scenario I want to demonstrate. But suppose that I have some command injection here. Now, don't bother too much with the details, but I can trick this machine here to execute any shell command which is to the right of this semicolon. And now I'm executing the DNS cat client, and I try to connect it to the ondehensikter.no domain. Now, again, keep in mind, the server on the left-hand side has a watertight outbound firewall. I would not be able to make any requests to any website or any other protocol anywhere on the web, except DNS, because I have to allow DNS. You may wonder, how did this binary end up on the server? Well, I cheated a little bit. It was part of the container image from which I built this app. But I could very well have assembled this binary on the back end by piping some base64 snippets and then reassembling them in the back. Something like this. But I have not prepared a script to do this, but believe me, it would work. So this entirely implausible scenario is still kind of plausible. Okay. So now I'm turning off my bind, because only one service can listen to port 53 at any given time. Okay. Now the server is listening, waiting for some compromised machine to connect to it and establish a DNS tunnel. Now, I'm hoping this works. Well, it looks like it doesn't, but that's why I've created a video. Wow, resolution was poor here. This is better. Now, the server got the initiating request, and interactively, I established a cell session with my compromised client. Now I have a shell. I typed ls, and I got the output from my compromised client: help, index.php, and source. Those are the 3 files in the working directory of this DNS cat binary that I tricked the compromised machine into executing. So I'm in. And I must re-emphasize, the firewall belonging to the app on the left-hand side is all but watertight. It allows DNS, nothing else. But still, this can happen. No, ICMP is blocked. Yeah, that's a bit ironic, but that would not work. Okay, so now you've seen how bad it can get. So how do you prevent this from happening? The way I see it, there are in general 2 different approaches. The first one is to monitor your DNS traffic, detect DNS tunnels when they are happening and stop them as soon as you can. And the other approach is to maintain a strict allow list of which DNS zones the client is allowed to make lookups to in the first place. And then you would stop the DNS exfiltration before it is ever allowed to be initiated. So, about approach number one, you would have some algorithm, some AI or whatnot that would scrutinize the DNS traffic and look for idiosyncrasies of DNS tunneling clients. This would typically involve very many TXT record lookups with very long query names. If you're seeing that in your DNS logs, you should sound the alarm because something bad is probably happening somewhere in your infrastructure. Now, the cons of this approach is that a single outgoing DNS request might be enough. It might be critical. If the attacker is able to guess the environment variable which contains the database password in a log4shell scenario, then it doesn't matter if you're able to stop the DNS tunnel after it has begun. And the other con, to the best of my knowledge, DNS tunneling detection is only offered by these pricey enterprise-grade firewalls. You cannot do it with open source components, to the best of my knowledge. You can correct me if I'm wrong after the presentation. I'd love to hear more about it. But based on my non-exhaustive research, you have to pay for this. And the second approach, the disadvantages here is that you can only apply this defense mechanism to machine clients. A human would usually resolve quite a lot of domain names through any workday. And it would be a nightmare to maintain and operate an allow list and accommodate requests from human users who want to open this and this domain. I see that it's hopeless. And even if you do have machine clients, you need to not have too many of them which are allow listed by the same resolver. So each box which filtrates DNS requests, it must have few clients or this approach will fall apart. Now, it is possible to do this with enterprise-grade firewalls. I see that many of them have this feature where you can have one allow list for one source IP and another allow list for a different source IP. But this assumes that you know the outbound IPs of all your various applications with various requirements to their DNS allow lists. And at least not in Equinor's landscape, this is not the case. We generally don't have static outbound IPs from various applications. So this approach is difficult to pull off. Now, is DNS being filtered? Yes, but it's a lot more common to detect it than to block it. There's a typo here. I mean, approach 1 detection seems more common than allow listing. And it looks like at least these 6 well-known enterprise firewalls offer DNS filtering in some capacity. Probably Palo Alto as well. I have not included that on this list, but I believe it's also true for Palo Alto. The first time I got aware of DNS allow listing as a concept, it was when I read this thread on Reddit on r/sysadmin. There was this popular post. What is the most stealthy way you have observed that traffic was hidden and sent out of your network? And the most popular reply was, yeah, data exfiltration via DNS queries. Swamp me. I knew about that before. But then I saw another reply to that reply by the user Charian. And he said, yeah, this is exactly why our high security network only allows DNS to a single server that is whitelisted on what it will recursively query. And I was like, that's pretty clever. Why is no one else doing it? Why have I never heard of it before? And why should you limit this approach to high security networks? Why not do it everywhere? In this modern paradigm of small containerized microservices, we would actually be able to apply a very short allow list to each individual environment. So I think this approach is feasible everywhere, not just on very special high security networks. Now, some context about the work I do at Equinor. I'm a platform engineer. I work on the Radix platform. It was launched about 5 years ago. It powers 250 applications, I believe. The number is rising fast. My product owner is sitting right there. He would know. It's open source. The core components are a Kubernetes operator, a set of custom resource definitions, a website API, and a user interface. There are somewhere between 10 and 15 microservices involved. Now, the end user experience for the developers in Equinor is that they provide a Docker file and a short infrastructure manifest, and we do the rest. So here's an example of a Radix config file. So I have a list of components here, where each component roughly corresponds to a Kubernetes deployment. But we have a lot fewer fields than a Kubernetes deployment in order to make sure the developers don't do anything funny. And here's a list of environments where each environment corresponds to one Kubernetes namespace. And in this example configuration here, I have 2 environments for my app. I have one which I've called with DNS rules. And inside this namespace, pods are not allowed to query any other domains than vg.no and anything under the equinor.com zone. Yeah. So under normal circumstances, this is what DNS resolution in a Kubernetes cluster would look like. I have all these namespaces, and all these namespaces contain all these pods, and they all send their DNS requests directly to core DNS. One DNS resolver to rule them all. But what if you inject a dnsmasq pod inside each namespace where you funnel through the DNS requests, where each dnsmasq pod has a configuration file where it would either allow or block outgoing DNS requests. Spoiler, that this is the implementation for this feature you're seeing here in the radixconfig.yaml file. If I specify allow DNS zones here, what will happen under the hood is that the Radix platform will inject this pod into the namespace, and it will take care of the DNS resolution for you. And the pod will be equipped with a configuration file, which is parsed at runtime, which will either block or deny requests according to these specifications. So, I have yet another demo for you. Now, we are repeating the first scenario with a log4shell application. But this time, it is hidden behind the dnsmasq proxy. Now let's see. I replace the user agent header. I again want to know the value of the Radix git commit hash. Okay, let's forward it. Again, I'm inspecting my bind logs, and nothing appears. Well, let's check the logs of the dnsmasq pod inside the namespace from which I'm calling. Look at this. Query was refused because it did not comply with a list of allowed DNS zones. So, this attack was stopped dead in its tracks. No exfiltration here. And again, I repeat the experiment with the DNS tunnel. I tried executing it. Nothing happens on the right-hand side. But let's check the dnsmasq logs. And there we go. The client is continuously trying to send these TXT requests to contact my evil name server, but it fails because dnsmasq won't let it. Yeah. Let me try to get full screen again. Okay, I have looked into some other alternatives to achieve the same behavior. Maybe some of you are thinking, okay, core DNS, it has this ACL plugin, which supports something like this. Why didn't you try that? Well, just like those pesky enterprise-grade firewalls, it requires the source IP of each individual application to customize the allow list. So it was not scalable. I would have to have one big allow list for the entire cluster, and that's not what I want. What about actually using an enterprise firewall? Okay, sure, there's a price, but if you paid it, would it work? Well, I haven't seen that any of them support this use case, where you could deploy one instance of the firewall as a pod into individual Kubernetes namespaces. I haven't seen that any of them support this type of configuration. Maybe some of them do. I would be very surprised, but if they do, please let me know. I'll dig into it more. And there's Istio, like that magic service mesh, which can do almost anything you could possibly want to do with the traffic in a Kubernetes cluster. There was a talk by Steve Wade, his name was, yesterday. He's one of the he's a contributor of Istio, and I asked him about this, and he was not sure if this, if I could have achieved this using Istio. He thought it was like 50% sure. So there are many examples using Istio on how to manipulate DNS traffic, but they are all about optimizing performance, not about denying malicious requests. But maybe I could have made it work. Now, this intercepting pod, which keeps track of which DNS requests are good and which are bad, could I have replaced it with something else? Well, yes, almost certainly. I probably could have containerized bind, and I could have used unbound, another DNS resolver, and probably several other alternatives. I chose dnsmasq simply because it seemed simplest to configure. Yeah, but after presenting this concept, people often ask me, Magnus, what's the point? My firewall is wide open anyway, and an attacker who needs to send data out of my app would just send HTTP, and no one would stop him. And I'm like, yes, that's another problem for another talk. And I have approaches to mitigate that as well. To summarize very succinctly, it involves yet more layer 7 proxies, some Azure-style private links. Regrettably, my talk on this topic was not approved for this conference, so you won't hear more about it. But I have cards up my sleeve there as well. And a big reason for why it is so hard to maintain a strict outbound firewall these days is that a modern containerized app will often consume some third-party API in the cloud, like, for example, Azure Functions. And if you do, then you need to open outbound to a very big IP mask. And an attacker is at liberty to create his own Azure Functions instance and send traffic home to himself. So if you have to allow all of Azure Functions, then your firewall is doomed. Yes, that was it. There is time for questions.
What do you do with the data from dnsmasq? Like the refuse, do you collect it and use it for?
You could very well collect it. I would maybe set up an alarm that triggers if some unexpected request makes its way to the intercepting proxy. I would certainly log it somewhere. It would be interesting.
It seems like a good indicator of compromise if there's something unexpected happening.
Yes.
It could, of course, be that you just forgot to add something.
Yes.
So this dnsmasq tool, was it created for this purpose specifically?
No. The primary purpose is, again, performance optimization, minimize redundant DNS requests. It was published in 2002. It's really old. Published before Dan Kaminsky's talk, where he alerted the world of DNS tunneling.
Okay, a follow-up question on that. Your implementation now is was that open source? And
Yes, it is.
Is it used anywhere else, as you know?
No, it's not. So the Radix platform, it is inspired by similar projects at Nav and Finn, but it is our own product, and it is not being operated anywhere else in Equinor. And my implementation of this feature, it's only compatible with our platform. Okay, seems like we're out of questions. Thank you.